Welcome to Lesson 5.4. This lesson broadens your tools with your identities and allows you to find values that normally you can't with the unit circle, just alone. So what you see on your screen, these are the notes I gave you for this particular lesson. These are the sum and difference identities. I want to highlight just a couple things about them. So first, being sum and difference, you have addition and subtraction for the main three trig functions. If you notice for the sine, sum and difference, it keeps the same sign that you're dealing with. So if the sine of a sum is going to have a sum, the sum of a difference is going to expand to a difference. Also, if it's the sine of a sum or difference, you have the sine of the first term and then the cosine of the second term, plus the cosine of the first term and then the sine of the second term. And the same thing when you are doing the difference. When you have the cosine sum and difference, if you're working with a cosine sum, it goes to a difference, expanded. If you have the cosine difference, it expands to a sum. And when you take this value, you take the cosine of both terms minus or add the sine of both terms. So it's a little bit different. You've got to memorize these. Okay? And the tangents are different as well. If you are taking the sum of a tangent, then the numerator is the same sign. It's also the sum, but the denominator would be different. And if you notice, then you're going to take the tangent of both terms, add them, but then on the denominator, you have 1 minus the product of the tangents. And likewise here, if you're taking the difference for a tangent, the numerator is the same difference, but then the denominator is a sum. So just become familiar with these. You will as you use them, and you need to have those memorized. Let's try an example. If I want you to find the exact answer for cosine of 165, exact means you can't just pick up your calculator and tell me what cosine of 165 is. I don't want the decimal value. I want the exact answer. Well, you can't go to your unit circle and find the cosine of 165. So we need to expand it, and we need to find some values on the unit circle that add to 165 that we do know. And I'm going to pick the cosine of 120 plus 45, because I know both of those. And you can arbitrarily, you just pick values that add up or subtract to the value that you need. Let's think about where that is on the unit circle. 120 would be right about here. And 45 is, of course, right there. Okay. Now I'm going to expand this using my sum formula that I have on the top. So that means that that equals the cosine of 120 and the cosine of 45 minus, because remember the sign is different, the sine of 120 and the sine of 45. And simply pull the values off the circle that you already know. The cosine at 120 is going to be a negative 1/2. Cosine at 45 is obviously the square root of 2 over 2 minus. The sine here at 120 would be the square root of 3 over 2. And the sine at 45 is square root of 2 over 2. Then, now it's just algebra. All right, so this is going to give me negative square root of 2 over 4 minus, this is going to give me square root of 6 over 4. I already have a common denominator, so I can simply add those two fractions, and I'm just going to leave it negative square root of 2 minus the square root of 6 over 4. I cannot reduce these because the 2 and the 6 are protected within that square root. I'm done. All right, let's try another one. Let's try a tangent. They're fun. All right, so I've got B. Let's do B. We're going to also find the exact answer of tangent of 11 pi over 12. So again, I have to find out, I have 11 pi on the circle, but that's 11 pi over 6, right? This is 11 pi over 12. So I'm going to change that to the tangent. I need 11. I'm going to change that to 9 pi over 12 plus 2 pi over 12. That gives me 11 pi. But what is 9 pi over 12? That reduces to 3 pi over 4, and this reduces to pi over 6. I have values for both of those, right? The tangent, let's see, 3 pi over 4 is right here. Pi over 6 is right here. So I can do that. Now we're going to go up and we're going to use, this is a sum for a tangent, so we're going to use this formula right here. We're going to take the tangent of each value. So I've got the tangent of 3 pi over 4 plus the tangent at pi over 6 all over 1 minus the product of those. So the tangent at 3 pi over 4 times the tangent at pi over 6. Now we're going to simplify this. Let's scoot this up a little bit. The tangent at 3 pi over 4, over here, that's a negative 1. Plus the tangent at pi over 6, that is square root of 3 over 3 over 1 minus the product of negative 1 and square root of 3 over 3. I'm going to clean that up. That if I get a common denominator in my numerator, this needs to be a 3, right? So this is going to be negative 3 over 3. So when I combine that, I will have negative 3 plus square root of 3 over 3. That's my numerator. Down here in the denominator, this becomes, this is really plus, right? And now I also need a common denominator of 3, so it's going to become 3 over 3. So this will combine to be 3 plus the square root of 3 over 3. When I flip that and multiply, my 3's are going to cancel, and I will be left with negative 3 plus the square root of 3 over 3 plus the square root of 3. Now you may think that we're done, but that is not rationalized, and we can't leave a square root in the denominator. So we need to rationalize that wonderful feature. And when we do that, to get rid of this square root of 3, normally we would just multiply by square root of 3 over square root of 3, but that sum is going to require us to do a 3 minus the square root of 3. Because now, when I FOIL those two terms, then my square root will disappear. Okay, it's a bit of a mess. You can do this. It requires a little bit, let's see, I'm running out of room, so I'm going to come up here. You just got to take each term, all right? So negative 3, let's do the numerator. Negative 3 times 3 gives me a negative 9. This term gives me 3 on the square root of 3. The outside term gives me another positive 3 on the square root of 3. My last two terms, square root of 3 times a negative square root of 3 gives me a negative 3. That's the numerator alone. Now if we FOIL the denominator, we're going to also have 9. Then we're going to, you see how this will give us 3 on the square root of 3 and negative 3 on the square root of 3. So they're gone. That's good. And then my last term is just simply a negative 3. Now let's clean this up. Negative 9 minus 3 is usually negative 12. A 3 on the square root of 3 plus 3 on the square root of 3 is 6 square roots of 3, all over 6. So I can now factor out a 6, for that matter. If I make two fractions here. So I would have negative 12 over 6, which is a negative 2. And 6 over 6, which cancels, so I'm left with just the square root of 3. That is my final answer. Now, a lot of you are going to get to here. I mean, there was a lot of work involved to get down to this answer. You had to pull the values, you have to know the formula, pull them off the circle. do the proper math, simplify, get to this, and then you have to rationalize. So there's a lot of room for a little bitty error, so you've got to be careful when you're working these. All right, let's try another example. Sometimes you'll be asked to simplify an equation instead of just find the answer. And if you look at this example, that's got cosine 25 degrees times cosine of 15 minus the sine of 25 times the sine of 15 degrees. You don't know the cosine, or you don't know the values of 25 degrees or 15 degrees on your unit circle. So you pull out these formulas. And if you recognize the pattern in this, if you see that it's got a cosine times cosine and a sine times sine, you recognize that that is one of the cosine sum and difference formulas. And if it has a subtraction sign here in the middle, then you know that the formula used is the sum. So this combines to the cosine of 25 degrees plus 15 degrees, which is simply the cosine of 40 degrees. And that's all it wants. That's all you can simplify. You don't need to get the exact answer from there. You don't need to continue going back to, find a value on the unit circle. You can stop. Now I'd like you to get the example that I pulled out of your book, and I typed it up just so that it would be easier for you to put in your notes. And I'd like you to get that, tape that down, and let's talk about this one for just a minute. This is example 3, and I took this from your book. This is the guided practice problem after another example that they do in your text, and that's why it says an alternating current I in amperes of another circuit can be found. The other circuit is the one obviously they did in the example. After t seconds using this formula where 285 degrees is a degree measure. And the first thing they'd like you to do is to rewrite the formula in terms of the difference of two angle measures. Now, if they don't tell you whether to use difference or sum, you get to pick. But they want you to rewrite it using a difference. So the first thing I did was, let's see, this formula is 2 sine of 285 times t. And I changed that to 2 sine. It had to be a difference that I could use with the unit circle. So I picked 315 minus 30. Again, there's probably another difference you could pick, but that's the one I selected. Then for part B, it says use a sign difference identity. That would be this difference one, to find the exact current after 1 second, which means I'm letting t equal 1. Okay, if t equals 1, then what do I have? Well, then I'm just going to expand this. I have 2 times, and then go back to your difference formula for the sine. That would be the sine of 315 cosine of 30. Minus, because it's the same SIGN, sine, and then I would do the sine of 30 and the cosine of 315 times the 1, because we're letting t be 1. Now let's go to our circle and let's find these values. Now remember that 315 is right down here, and 30 is obviously right here. Okay. I'm already at 14 minutes, so I'll tell you what, we're going to break here for video 1, part 1, and I'll come back in part 2 and we'll complete this problem. Thank you.